Welcome to the lecture series. In this lecture series, we are discussing about the supervised and supervised learning techniques. So in this series, in this lecture, we will discuss about the logistic regression. Logistic regression is a fundamental supervised learning algorithm which is used primarily for classification tasks. Despite its name, it is not used for regression, but rather for predicting the probability that can be given input belongs to a specific category. So it is a statistical method for analyzing a data set in which there are one or more independent variables that determine an outcome. So it predicts the binary outcome, uses sigmoid function to map the predictions to the probability, and here we used for medical diagnosis, spam detection, credit scoring, etc. And it is a classification algorithm technique. So difference between this linear and non logistic is, here you can see it contains a straight line to separate, where it contains a S curve. So the prediction lies within the range, whereas here the prediction can exceed 0 to 1 range. So here itself you can see the curve of separation. And how it works is, it uses a sigmoid function, that is a linear combination of input features, and passes it through a mathematical function called as sigmoid. And linear foundation we have, it starts like a linear regression by calculating z is equal to omega w into x plus b, and sigmoid function any real valued number into a range between 0 and 1, which can be interpreted as a probability. And third important term we have to know is decision threshold. A default threshold, usually 0.5, is applied to this probability to assign a final class label. For example, if the probability is greater than 0.5, the model predicts class 1, that is spam. Otherwise, it predicts class 0, that is it's not spam. So this is a basic example for this sigmoid function and logistic regression. And next, coming to understand the user needs, why we want to go for this logistic regression is stakeholders interviews. We have to understand the classification needs, and here we have to examine the data characteristics, and next we have to identify the pain points in the current prediction level. So we can use interviews, observations, surveys, and data analysis. We can go with the feature import to find out the feature importance, to find out the data patterns, and prediction of accuracy. And now the main problem here is to transform user insights into an actionable problem statements for logistic regression. So we have to identify the core challenges, we have to define the success metrics, and we have to establish the problem scope and constraints. And coming to the brainstorming solutions, we can explore the feature engineering techniques, consider the regularization methods, and we have to identify the model variations. So we have types of logistic regression techniques also, like binomial and multinomial and ordinal. Binomial is for two possible outcomes, either yes or no, but that is pass or fail, etc. Multinomial, we have more than three or more underorder categories, like it may be identify whether it is a cat, dog, or bird. Ordinal for categories which are natural ranking, that is low, medium, high, etc. So coming to the key difference, as we discussed to the earlier, we have in linear we have the continuous linear is used for continuous prediction, and logistic is used for categorical separation. And equation also, any real number we can use, like minus infinity to plus infinity, where in the logistic we can only have probability of 0 and 1. And in linear we are using mainly for forecasting and trend lines. And logistic regression, we mainly use it for classification, probability estimations. And coming to the roadmap, yes, we have a mathematical function, we implement it, we evaluate it, and we go for the robotic application. So major practical applications include healthcare, like predicting likelihood of a disease based on symptoms, and finance, where detecting fraudulent credit card transactions or loan approvals. Marketing, estimating the probability that can customer will click on ad or buy a product. and in email, whether identifying it incoming message is a spam or not, etc. So here we have lot of applications. And next is we will discuss regarding the other clustering techniques and algorithms. And finally, logistic regression provides a interpretable classification results, enables the decision making in robotic systems, and integration with the deep learning enhances capabilities. So in the next lecture series, we will discuss with the another upcoming algorithms. Thank you.